So we're going to end up stopping at 43. 44 it's structurally the same as the other three problems on this page, but it's a little bit uglier because it would have harder factoring. I'm going to do 42 and 43, have you do 41. In 42, I'm going to square both sides to get rid of the radical. The dangerous thing is it's hard to square that right-hand side. When I'm squaring the right-hand side, I have to put the right-hand side in a parentheses, and squaring is tricky on that right-hand side. The left-hand side, when I square it, I just get the x plus 1. The right-hand side, when I square it, I need to create two parentheses with the same sign in it and do the 4 multiplications. To simplify this side, I do x times x, x times minus 5, minus 5 times x, and minus 5 times minus 5. So this is going to give me x squared minus 5x minus 5x plus 25 for the starting of simplifying the right-hand side. When I square the right-hand side, that's a binomial. I wrote it as two identical parentheses with the same signs. Now I'm going to combine these minus 5x's. Because they have the same signs, I'm going to add the 5's and keep them negative. I snuck a 1 in front of the x on the right-hand side. I thought it was going to make my life easier. Now I'm going to get it equal to 0, keeping the x squared positive by minusing 1x and minusing 1. On the right-hand side, I'm making a 0 happen. Left-hand side, I made a 0 happen. On the right-hand side, I bring down the x squareds. The x's both have negatives in front of it. I'm going to add the numbers and keep them negative. The 25 and the 1, when you subtract them, you get 24. Now I need to make the right-hand side factor into two parentheses. And the numbers need to be minus minus. They need to multiply to 24. And they need to add to negative 11. It's going to be negative 3 and negative 8. Because negative 3 times negative 8 is positive 24, and negative 3 plus negative 8 is negative 11. So on the right-hand side, one of the parentheses gets a minus 3, the other gets a minus 8. It doesn't matter which parentheses gets the 3 and which gets the 8. Now that I have it factored, I'm going to go x minus 3 equal to 0, x minus 8 equal to 0. For the x minus 3, I'm going to add 3 to both sides and get x equal to 3. For the x minus 8, I'm going to add 8 to both sides and get x equal to 8. Always before I check, these aren't actually solutions, they're just potential solutions. And I should see whether they're solutions or not by physically checking. I'm using my calculator because it doesn't make as many mistakes as I do. The original problem in problem 42 is the square root of x plus 1 equals x minus 5. To check the 3, I do the square root of 3 plus 1 equals 3 minus 5. Let me just check that. Left-hand side, square root of 3 plus 1 is 2. Right-hand side, 3 minus 5 is negative 2. That's what happens when I do good math, perfect math, no math errors, but generate a solution that doesn't check. So x equal to 3 is not a solution. It's an extraneous solution. Now let me check the x equal to 8 and do the square root of 8 plus 1. See if it equals 8 minus 5 just by changing both x's to 8. Left-hand side, square root of 8 plus 1 is 3. The right-hand side, 8 minus 5 is 3. That is a solution. When I go to write my answer for problem 42, it's probably best just to say x equal to 8. It's okay to say x equal to 8, x equal to 3 doesn't check, or use the word is extraneous. So we have 41 and 43 that we want to do. I almost think I don't know which one. I don't think they're any harder. 41 and 43 I think are equally hard. I'll do 41. I'll let you do 43 for homework. And to get started on 41, I'm going to square both sides. Throw parentheses around the left-hand side, on the right-hand side. On the left-hand side, when you square it, you just get the x plus 2 that's under the radical. On the right-hand side, to square it, I need to create 2 parentheses and do the 4 multiplications to do the multiplication to clear those parentheses. The multiplications is x times x, x times minus 4, minus 4 times x, and minus 4 times minus 4, which is x squared minus 4x minus 4x plus 16. Those 4x's have the same signs, so I'm going to add the numbers and keep them negative. Minus 4x gives me a minus 8x. Gotten rid of the square root, gotten rid of all the like terms. I have that ugly square, so I need to set it equal to 0. I'm going to minus 1x and minus 2 from both sides. On the left-hand side, I minused everything and made a 0. On the right-hand side, in front of the x's, the numbers have the same sign, so I add them. The numbers have opposite signs, so I subtract them. Now I need to factor. My factors need to be double minus. My numbers have to be minus minus. They have to multiply to 14 and add to negative 9. And that's going to be negative 2 and negative 7, because negative 2 times negative 7 is positive 14, and negative 2 plus negative 7 is negative 9. So when I go to factor this, this is going to be x minus 2 times x minus 7. First I'm going to set the x minus 2 equal to 0, add 2 to both sides and get x equal to 2. And then I'm going to set the x minus 7 equal to 0, add 7 to both sides and get x equal to 7. Again, those aren't guaranteed to be solutions, and these problems where I'm solving by factoring, usually the algebra produces 2 solutions, one checks and one doesn't. Theoretically, they both could check. Theoretically, neither could check. I'm kind of shy on room here, so let me do the checking. The original problem in problem 41 is the square root of x plus 2 equals x minus 4. I'm going to check the x equal to 2 by seeing if the square root of 2 plus 2 equals to 2 minus 4. So square root 2 plus 2. Left-hand side comes out to be 2. Right-hand side comes out to negative 2. The x equal to 4 is not a solution because I get that not perfect checking. If I wanted to check the x equal to 7, I'd see if the square root of 7 plus 2 equals 7 minus 4. Square root of 7 plus 2 is 3. Silly to do a calculator for 7 minus 4, but 7 minus 4 is also 3. So 7 is a solution, while 2 is not a solution. When I go to write my answer, it would be best just to say x equal to 7. It would be okay to say x equal to 7, x equal to 2 doesn't check, and the fancy word for doesn't check is extraneous. Kind of the root there is extra. It's an extra solution that the algebra comes up with that doesn't belong in your answer. That's far enough. There's a few more problems beyond problem 43 that we'll skip over. They're grungy, and I almost think a little too much for an intermediate algebra course. So we'll call it quits here. We just have one section left, section 4.10. Super easy section. Section where this calculator also earns its money. If I haven't motivated you in this chapter to break down and buy this calculator, you might want to get it before you get section 410. I mean, it's lovely that it does these prime factor trees so nicely. It's lovely that you can do like 6 square root of 5 plus 2 square root of 20, and it just rips out an answer for you. It's so nice. It's going to be equally nice in Chapter 5, well worth the investment. So I'll pause the video and we'll get to 410 when we get to it.